Oh, what a glorious thing to be a healthy, grown-up, busy bee, whiling away the passing hours.
Ladies and gentlemen, welcome to my workshop. This video is an introduction to a number of shop-made tools and accessories which I've made over, well, a number of years. And I'll just quickly run through what they are. Left foreground is the cylindrical grinding attachment for the surface grinder. Behind that is a travelling steady which I made for the lathe. Next to that is the tool grinding rest designed by Harold Hall. On the right of that is the boring and facing head, which is an enlarged version of that by Graham Meek from his book, and also published in Engineering in Miniature. I have here examples of low profile clamps which I use on the mill. This strange looking device is somewhat overkill tool for setting the angle of the top slide on the lathe. And finally for this one is a radius cutting tool based on a design which I got off the internet, but modified, I think, to improve it, and it also has modifications to allow concave as well as convex radiuses to be formed. Following this video will be brief descriptions of the low profile clamps and the angle setting gauge for the tool post. The other tools and tooling will be subject to separate videos, none of them very long, so you won't be bored for a great deal of the time, I hope. If you have been, thanks for watching, and the upcoming videos, as I say, the top slide angle setting gauge and the low profile clamps. You find me now at the lathe with the top slide angle setting gauge clamped between the 3-jaw chuck here and the tailstock drill chuck. The tool itself consists of 2 parallel rods. The lower one in this position is the one that is clamped between the 2 chucks. The top one is held solidly in this block and slides in this block. The 2 sliding blocks are held together by 2 arms. This length and this length is identical. There is an overlapping piece here with a grub screw which allows fine adjustment of the resting position. When held in the vertical plane, these 2 rods in place, well, in my case, a magnetic digital protractor on there, difficult to balance, but you get the idea. You now read that. In my case it reads 0.5 degree off horizontal, but no matter, because this is a relative position measuring. You place that on the side arm, read that, and that is also 0.5 degrees. And as I say, there is a grub screw here. You can alter the relative arrangement so that that and that are parallel. Now let us say you want to cut a 60-degree included angle thread. So you will need to set, for one method of doing it anyway, the top slide over to 30 degrees. You can of course use the graduated dial on the top slide itself, although on this lathe there is no registration mark against which to measure the angle, and it is of necessity a not particularly accurate means of setting the angle, at least not on this lathe. So in order to get the correct angle, we raise these levers, slide the block along, and I've switched it off now. Let's put this back on. There we go. Clamp that on there until we get an angle of, in our case, the angle required is 71 degrees. There we go. Getting there. In fact, we need to make it 71.6, of course. To 0.5, I mean, in order to compensate for the slightly off. There we go. Tighten up the screws, recheck that angle. And now we turn the top slide over, out of the way, bring that down to the horizontal, and bring that up so that it is parallel with no shake. I'll try and move the camera without shaking it too much. And we have the top slide set against that angle, angled leg, and the top slide is now set at the required 30-degree included angle, or half included angle. Simply now a matter of nipping up the top slide locking screws, and away you go. Simple to produce, accurate, and I think I said before, a bit of a sledgehammer to crack a nut, but an interesting exercise anyway. Thank you for watching. Next up will be the low profile clamps. This short video will demonstrate the use of my design of low profile clamps on the mill. This setup is designed to show how it could be used in the situation of holding this irregularly shaped piece of aluminium in this case. I take it away. You'll see that although they're not actually clamped to the table, the clamps are very simply two pieces of machined steel. This piece is clamped to the mill table with T-nuts, and this secondary piece, the jaw if you like, with two dowels, silver steel I've used, in a sliding fit in the fixed piece. There are grub screws through the fixed piece which bear on the ends of these pins so that when it's set up as you saw just now, by screwing the grub screws in, the movable jaw is pushed out against the workpiece and it holds it securely. Each pair has been manufactured slightly differently, or it's in pairs. This one has a step 10 millimeters deep. That holds the work obviously 10 millimeters off the table. This pair, again 10 millimeters but stepped back, and has also got a stop in there which can be used to prevent the work from moving in that direction. I've also got similar pairs of jaws, a little rusty unfortunately, but that has a 5 millimeter step, and I've also cut a V in there so that if necessary, or if you want to, you can flip it upside down and hold a cylindrical piece of work in between the jaws as well, or indeed hold a radiused corner. Simple clamps, easy to make although time consuming. The main problem being to get the dowels to run smoothly within the clamps. However, effective, and I've used them on many occasions to hold odd shaped pieces of work. That's odd shaped after I've made them. Hope you've enjoyed that little show, and coming up next will be one of the other tools. Hope to see you soon.